complete and net ionic equations. Let's write this equation uh, first. Ammonium phosphate. Ammonium is the polyatomic ion NH4. Phosphate is PO4. The charges on these are 1 positive and 3 negative, so we're going to use these charges, crisscross them to get the ratio to get the formula unit. So we're going to have 3 ammoniums in this compound, so we'll need a parentheses there and get a 3 over there. This is all of these are in solution of water, so we'll put AQ there for that. Zinc nitrate. Zinc is a here. Zinc has a 2 positive charge, so we're going to crisscross that down out here. Nitrate is a 1 negative charge, so we don't need to crisscross that 1. We don't write ones, and then that's also in solution. These are all soluble. Got my hair stuck. Okay, sorry about that. All right, this is a double replacement precipitate reaction. We're going to crisscross the, exchange or switch places the cations. I'm going to write the one that dissolves first, just because that's all right. Ammonium nitrate is soluble. All nitrates are soluble. Ammonium is soluble, so 1 negative, 1 positive. They're going to crisscross and cancel out. So this is just our formula unit for ammonium nitrate. I put AQ there for soluble. Now the other one, phosphates are generally insoluble, so zinc, phosphate, that's going to be our solid. Okay, get the formula unit. This is a 2 positive cation. Phosphate is a 3 negative anion, polyatomic anion. So crisscross those charges. I'm going to get a 2 out here and a 3 over there. All right, let's balance this equation. All right, we got 3 ammoniums on the reactant side and only 1 on the product side. So we're going to need a 3 over there. That's going to update the nitrates to, oh, yikes. Okay, hold on, let me back up here. All right, I'm going to do the zincs first. All right, I need a 3 there because I have 3 zincs on the right side. That's going to give us 6 nitrates on the reactant side. So I'm going to need a 6 there to get 6 nitrates on the product side. I also have 6 ammoniums, right? And I have 3 on the reactant side, so I need a coefficient of 2. That means I have 2 phosphates, and that should be what I have on the product side. So coefficients are 2, 3, 6, and 1. Okay. Now, to write the complete ionic equation, we need to dissociate or separate all these compounds that are that are soluble. Okay, and we need to separate them into their ions. So there's going to be 6. All right, this 3. If we keep it there, it means they're still stuck together, and they're not. So we need to quantify it in terms of moles. So 3 times 2 is 6 moles of ammonium. Put a charge there for all of these ions. AQ, they're still dissolved in water. Phosphate, all right, there's 2 moles of them. And this is not the most important thing because you can always balance them at the end again, but try to get this all done as we're doing the problem. Phosphate is a 3 negative polyatomic anion. All right, we got 3 moles of zinc. Zinc has a 2 positive charge. And then we got 3 times 2 there. We have 6 nitrates, 6 moles of nitrate. That's a 1 negative charge. And over here we got 6 ammoniums. um, 6 nitrates, and this is your precipitate, so we're not going to dissociate that. We're just going to write that the way it is. Oh, sorry. That's a solid. Just kind of running. I ran out of room. All right, no charges go on that. So neutral ionic compound that precipitates to the bottom of the beaker. All right. So oftentimes the ions on the side with the precipitate are going to be the spectator ions. So notice the ammoniums are exactly the same on both sides. They're spectators. And to get our net ionic equation, okay, so we just wrote here maroon is the complete ionic equation, right? After we cancel the spectators, we have the net ionic equation. All right, so just rewriting whatever we have left. All right, let's see. Are the atoms balanced? The atoms are balanced because we balanced them earlier, but are the charges balanced? We have 3 times the 2 positive is 6 positive, and 6 negative. That cancels out on the reactant side, and there's no charge on the product side, so we are good. This is your answer for the net ionic equation.